Shawty's like a melody in my head that I can't keep out. Got me singing like na 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 na. Every day's like my iPod stuck on replay, replay. Shawty's like a melody in my head that I can't keep out. Got me singing like na 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 na. Every day's like my iPod stuck on replay, replay.
Hello everyone, I am Singh. Welcome to Trust Me, I Am an Engineer game show. Nowadays, we can see that the main material that we use in construction is concrete, which have many types of it, and each type have its own property. So, our topic for today is workability and setting time. Today, our guests are from King Mongkut University of Technology, Chonburi. So, let's talk with them first. So here are our guests from King Mongkut University of Technology, Chonburi. Let's get known with them first.
Hello everyone,
Yeah,
bleeding team. I'm Jet.
I'm Thai.
I was scared to approach ya, but
Hi everybody, I am this Angfuk. We are from Holland.
Team.
she like a song played again and again. That girl like something off a poster. That girl is a gun they say. That girl is a gun to my holster. She's running through my mind all day. Shawty's like a melody in my head that I can't keep out. Got me singing like na 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 na. Every day's like my iPod stuck on replay, replay. Shawty's like a melody in my head that I can't keep out. Got me singing like na 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 na. Every day's like my iPod stuck on replay, replay.
Alright guys, do you want to play a game? Let's talk about question number 1. What is workability of concrete? Ready, set, go! Mr. Get?
Alright, for my answer is the workability is the property determining the effort required to manipulate a fairly mixed quantity of concrete. That's it.
Okay, let's see the explanation from Professor Jennifer Middown.
Concrete workability in the STM defined as the property determining the effort required to manipulate a freshly mixed quantity of concrete with minimum loss of homogeneity. Factors affecting workability. First, water cement ratio. A higher proportion of cement materials usually means greater strength and with the proper amount of water. More fat is coating the surface of aggregates for easier consolidation and a better finish. Second, aggregate size and shape. As aggregate surface area increase, more cement phase is needed to cover the entire surface of aggregates, so mixed with smaller aggregates are less workable compared to larger size aggregates. Third, admixtures. Many types of admixture alter the workability of fresh concrete, either by design or as a side effect. Some surfactants such as super plasticizer reduce attraction between cement and aggregate particles, allowing mix that can be quite flowable without the negative strength and segregation effects of too much water.
That is correct. Well done for the first one. Now let's move to the second question. And the question is, what method we use to test the workability? Ready, set, go! Mr. Fluke?
Protest is the final answer.
Well, the answer is not quite correct. Now let's see the correct answer from Professor Uzi Jagaji Huajai for more explanation.
For the workability, there are three methods to determine the workability. So the first one is concrete slump test, and the second one compaction factor test, and the last one VB concentrometer test. The slump test is the most simple and popular workability test because of its low price, and also you can get the result immediately. It has been widely used for workability since 1922. There are two methods for slump test. The first one, slump of hydraulic cement concrete, is used to find the workability, which indicates water-cement ratio. The slump flow test is used to assess the horizontal free flow in the absence of obstructions. In this video, we will focus on slump of hydraulic cement concrete by following STM C143 standard test method of slump of hydraulic cement test. The important to measure the slump test: measure workability of fresh concrete, which is not too dry or too wet. Ensure uniformity for different loads of concrete under field conditions.
Apparatus: mold, tamping rod, measuring device, scoop, slump plate, trowel. First, place the mold on a smooth horizontal non-porous base plate. Second, fill the mold with the prepared concrete mix in 3 approximately equal layers. Third, tamp each layer with 25 strokes. Fourth, after we remove the excess concrete and clean the mold and the base plate, place the mold from the concrete immediately and slowly in vertical direction. Fifth, measure the slump.
And next, for the types of slump, choose slump concrete subside, maintaining its general form. This slump is the desired form of slump that we require. The second one, shear slump. The top portion of the concrete shears off and slips sideways. And the last one, collapse slump. The concrete collapses completely, likely from the mix being too wet.
So now the score are 1 and 0. And we are now at question number 3. What is the setting time of concrete? Ready, set, go! Mr. Dis?
The time when the cement plate reaches its certain point of hardness.
Alright, now both of you are 1-1. Let's see the more explanation from Professor Toretto Kongyuman first.
The times of setting of hydraulic cement plate is determined based on the penetration resistance using a wire needle ASTM C191 or Gilmore needle ASTM C266. These methods are used to measure the time of setting hydraulic cement in plates at a standard consistency. The times of setting of hydraulic cement is primarily measured to ensure compliance with cement specifications.
Let's move to the question 4. And the question is, what method we use to test the setting time? Ready, set, go! Mr. Thai.
For my answer is penetration test.
Okay, this time we will see the answer from Professor Hikara Karuki first.
Setting time of concrete can be separated to initial setting time and final setting time. Initial setting time is the time at cement plate losing its plasticity and final setting time is the time at cement pad lost its plasticity and attain sufficient to resist certain definite pressure.
Setting time of concrete by following STM-C403 standard test method for time of setting of concrete mixtures by penetration resistant. For the important to measure the setting time of concrete, normally transporting, pouring, and surface finishing of concrete must be performed before concrete hardens.
Apparatus, loading apparatus, penetration needle, cube mold, pipette, tissue. Standard sieve number 4.
First, mix the ingredients of concrete. Also record the time at which initial contact was made between cement and mixing water. Second, remove all the mortar from the sample of concrete by sieve number 4. Third, remix the mortar and place it in the container in a single layer. Fourth, tempt the mortar. The mortar surface shall be at least ½ inch below the top edge of the mold. Fifth, insert an appropriate needle size depending on the degree of setting of mortar. Sixth, apply force downward until the needle penetrates mortar and calculate the penetration resistance. 7. Distance between needles shall be at least 2 times of the needle, but not less than ½ inch, and the size of the mold shall be at least 1 inch. 8. Make at least 6 penetrations with regularly intervals, 30 to 60 minutes.
After we get 6 penetrations, draw a curve of penetration resistance versus elapsed time. To find the initial and final setting times of concrete, initial setting time is the time when the penetration resistance equals 500 psi, and the final setting time is the time when the penetration resistance equals 4000 psi. So as we know the initial and final setting time, we can estimate the time for transportation also when we can remove the formworks.
So the score is 2 for the bleeding team and 1 for Porcelain team. The winning team is bleeding team. Porcelain team, don't be sad. You win the prize, which is $100,000.
Oh, thank you!
So I hope you get some knowledge from the show for today. Thank you for watching us. See you again next time. Bye!